All right, let's just dive right into this explainer. Today, we're tackling a massive, fundamental shift happening right now in the world of software development. We hear a ton of hype about AI coding assistants, usually right before they confidently write a massive bug into our code base, right? But today, our core mission is to move way beyond that hype. We're going to measure the actual, real-world productivity impact of autonomous agentic systems inside active engineering teams. We really need to ask the hard questions here. Do these agents actually make teams faster? Do they legitimately improve code quality? Or honestly, do they just create more work for us?
So here's our quick roadmap for today. First, we'll cover the agentic paradigm shift. Second, measuring developer productivity. Third, we'll look at 3 team integration models. Fourth, shifting developer sentiment. And finally, how infrastructure drives project velocity.
Starting off with Section 1, the agentic paradigm shift.
It is honestly fascinating to see where the industry is drawing the line in the sand between the old way and the new way. On one side, we've got your basic AI coding assistant. Think of the early versions of Copilot, right? It sits in your IDE and completes a few lines of code. It's basically a glorified autocomplete. But then, on the other side, we have true agentic coding systems, like Cursor in agent mode, Devin, or Claude Code. These things don't just complete lines. They autonomously plan how to implement a whole feature, they write code across multiple files, run the necessary tests, evaluate their own results, and actually fix failures as they pop up. It's just a totally different animal.
And this number is just wild to think about. Gartner projects that by 2028, 75% of enterprise software engineers will be using these tools. That's up from less than 10% in early 2023. We're talking about a 52% compound annual growth rate through 2030 just for the AI coding tools segment. So look, this isn't just some pilot experiment or a marginal little productivity hack. It's a massive structural change in how engineering capacity is organized and deployed across the entire enterprise.
So understanding how these advanced systems actually operate under the hood is absolutely crucial. A lot of the power comes from what we call multi-agent architectures, and these actually dominate over 66% of the enterprise market right now. Instead of one AI trying to do literally everything, you have an orchestrator agent. Think of it like a project manager coordinating multiple specialized sub-agents. One handles writing the code, one does the security review, another one runs testing. They work in parallel and synthesize their results together. It perfectly mirrors how a high-performing human engineering team operates, and it is vital for complex end-to-end tasks.
Okay, moving on to Section 2, measuring developer productivity.
So how do we actually measure the long-term ROI of these tools without getting totally bogged down in useless vanity metrics? Well, the source material highlights this brilliant metadata framework developed for a recent thesis studying SaaS organizations. It extracts metadata directly from tools like GitHub and Jira. And you might be wondering, why metadata? Because you can measure real, sustained impact without needing a heavy source code analysis tool to pry open your proprietary secure code base. It balances 2 critical dimensions for long-term project success: development velocity on one hand and software quality on the other.
Let's break those metrics down real quick. For development velocity, we're looking at pull request cycle time, basically how long it takes from opening a PR to actually merging it. We also look at overall PR output and Jira ticket throughput. But, and this is a big but, tracking pure velocity alone is super dangerous. If you only measure speed, you're just going to end up shipping terrible bugs at a record pace. That's exactly why we have to balance it with software quality metrics, specifically PR size and review intensity. Smaller PR sizes make it way easier for reviewers to spot errors, and tracking code reviews per engineer ensures that human oversight isn't just going out the window the second an AI writes the code.
Let's look at Section 3, 3 team integration models.
We're going to apply this framework to a central case study here. A Nordic B2B SaaS company that spent 6 months integrating agentic systems across 3 very distinct development teams. What's super interesting is how a broad mandate from management quickly morphed into vastly different adoption patterns down in the trenches. Team A was a small crew of 3. Their adoption was totally individual. Like one person didn't use the AI at all, while another used it all the time, basically acting as a lone wolf. Team B had 5 members, and they took a broad but shallow approach. Everyone used it, sure, but strictly as a selective pair programmer for very specific, limited tasks. And then you have Team C. This is a larger, cross-functional team of 12. Their approach was foundationally invested. They actively built shared infrastructure to support these agents. And, as we're going to see, these different approaches totally changed how the developers actually felt about using the tools day to day.
To really grasp why Team C won out, you have to embrace the newly hired junior developer analogy. We've all been there, right? An autonomous agent is essentially a brilliant, eager junior dev. It knows all the mainstream programming languages perfectly, but it desperately needs your company's specific, messy, totally unique context to actually survive. Without explicit context engineering, and by that I mean building reusable markdown files, defining your conventions, creating skills for the agent to reference, the agent is just going to fail at complex tasks. It simply does not know your legacy codebase unless you explicitly teach it.
That brings us to Section 4, Shifting Developer Sentiment.
How do developers actually react to handing over the keyboard to an AI? Well, the initial reaction is almost always skepticism. And honestly, can you blame them? The research shows that 40% of agentic AI project failures stem straight from inadequate infrastructure and trust issues. Developers really struggle with the black box nature of these agents. When a human colleague submits code, you generally trust their baseline competence. But when an AI submits code, developers often feel forced to scrutinize it line by agonizing line, which just completely kills their momentum.
You can really hear the frustration in this quote from developer P05 in one of the studies. They said, "I have to watch, understand, critique every outcome. What I pivoted to is spec-driven development, creating tasks that the LLM can blindly follow. Because reviewing AI code line by line is just exhausting, the really smart developers are shifting their entire workflow. Instead of writing code, they're writing incredibly rigorous technical specifications and implementation plans. They're basically becoming directors and evaluators rather than primary authors."
But look, sentiment isn't set in stone. Notice this massive, sharp spike in Claude code spending for Team C right around December 2025. What exactly happened there? Well, the release of much more capable AI models. The big takeaway here is that trust is earned. When the models actually got smarter, the developers immediately perceived the utility, and usage intensity just absolutely skyrocketed. They moved from asking simple conceptual questions to just letting the agents handle full end-to-end task execution.
And finally, Section 5, Infrastructure Drives Project Velocity. Okay, the moment of truth. Which team's integration model actually delivered the goods? Here we're looking at the average pull request cycle time for all three teams over a sustained 6-month period. Look at that blue line. That's Team C. Despite being a large team taking on complex work for a brand new product, their cycle time dropped significantly and maintained a really steady long-term pace. Meanwhile, Team A, the orange line, with that individually driven adoption, just fluctuated wildly. Team C's foundational investments in their infrastructure allowed them to handle way more work without slowing down at all.
And this is a super crucial detail right here. Take a look at this chart showing code reviews per active engineer. Notice that clear upward trend for teams B and C starting around February 2026? As the AI was trusted to write more code, the human review intensity actually had to increase. And this is exactly what you want to see. The teams were moving faster, they were producing more PRs, but they absolutely did not sacrifice quality. The human developers stepped up their review game to act as a vital check and balance against the AI-generated code.
So why did Team C absolutely crush it when it came to long-term project velocity? They didn't just buy a shiny new tool, they built an environment. They created reusable skills to give the AI proper domain context. They utilized automated agent reviews to catch the easy bugs, but strictly enforced mandatory human checks before anything merged. And most importantly, because they built a shared infrastructure, the crazy experiments of a few heavy AI users ended up lifting the baseline capability of the entire 12-person team. Which leaves us with one really vital question for every engineering leader out there. Are you just buying AI tools and crossing your fingers that your developers figure it out? Or are you actively building an AI-native engineering infrastructure? The research is crystal clear on this. Mere usage does not automatically translate into productivity. Foundational investment does. So take a hard look at your own team's readiness and ask yourself if you're truly prepared for Software Engineering 3.0. Thank you so much for joining me for this explainer, and keep learning out there.